Hi guys, this is our stats presentation.
We chose to do a chi-squared get as a fit test.
Enjoy.
Is there evidence that the distribution of people with real trees vs. fake trees in our school has the same distribution as the national average?
First, we're randomly selecting one of our classes except for Andrew because he's sick.
Jada got number 3. Yuki got number 2. Adam will auto get 1 because that's the last number.
So now we're randomly selecting a number 1 through 3. We selected 1, which is Adam.
This is a random selection of one of Adam's classes, and we got period 2.
That's our class.
Using the data, we made a self-frequency table. As you can see, 27 said that their tree was fake, and 3 said that their tree was real.
In this column, we have the national percentages, which is 77% fake trees and 23% real trees. In this column, we calculated 77% and 23% of 30 to get our expected values.
Conditions, so we had to ensure that we had simple random sampling. We also had to make sure that our sample size was less than 10% of RB families with Christmas trees. Additionally, we had to make sure our sample was large enough, and we had to check that our expected self-frequency was greater than or at least equal to 5, and we performed a goodness of fit test. Alright, this is our pie chart of national average fake versus real trees, and as you can see, 23% were real trees and 77% were fake trees.
This is our pie chart for real versus fake trees of families at RB. 10% had real trees and 90% had fake trees.
Next are our hypotheses. For our null hypothesis, we said the distribution of people with real trees versus fake trees in RB have the same distribution as the national average, and for our alternative hypothesis, we said the distribution of people with real trees versus fake trees in RB do not have the same distribution as the national average.
Doing some calculations, we found our degrees of freedom to be 1, our chi-square to be 2.86, and after putting it into the calculator, we got 0.09 as our p-value.
Based on the sample, because the p-value equals 0.09, which is more than alpha's equals 0.05, we do not have enough evidence to reject the null hypothesis. We cannot conclude that the percent of people with real trees versus fake trees out of RB families has a different distribution as the national average.
Okay, so to wrap up our presentation, we're just going to go over the main errors that we found during our project. So the first one was that we all share a class, being period 2. So in randomly selecting a class, the odds of our stats class ending up as the class we chose for our sample was probably greater than the chances of choosing any other class. And then our second error we found was that we used a very small sample size, which was our class size. And that was about it. Thank you guys for watching.